Welcome to The Explainer. I am so thrilled you're here with us. Today, we're diving into something that is literally changing the game for headless content delivery. By headless, we just mean serving up raw content without all the front-end design baggage. And the star of the show today? GraphQL in Adobe Experience Manager. Look, if you're building JavaScript-based front ends, React, Next.js, or mobile apps, and you want the absolute ultimate solution for high-performance delivery, well, you are in the right place. We're going to unpack exactly how AEM uses GraphQL to completely transform your dev workflow and supercharge your app's performance.
So here's our roadmap for today. We're going to look at GraphQL versus traditional APIs, how to use the GraphQL IDE, dive into AEM GraphQL integrations, walk through some real-world AEM use cases, and finally, wrap up with dispatcher and performance optimization. Let's get to it. All right, Section 1. Let's dive right into GraphQL versus traditional API architectures. To put it simply, GraphQL in AEM is an incredibly powerful query language. Its main job? To expose your structured content fragment data to all your downstream applications. Now, the absolute magic phrase you need to remember here is this. It allows clients to request only the exact content they need, nothing more. This is absolutely vital for making your front-end applications run efficiently. I mean, think about it. If your mobile app just needs a quick headline and a tiny thumbnail image for a newsfeed, why on earth should it have to download the entire article body, the author's bio, and these massive high-res images? It shouldn't. It just needs those two specific pieces of data.
Actually, a great way to think about standard HTTP REST APIs is like a rigid set menu at a restaurant. You want the steak, but you're forced to get the soup, the salad, and the dessert too, whether you actually want them or not. Standard REST APIs require multiple requests for fetching one object at a time, and they constantly suffer from this thing called overfetching. Your app gets these massive payloads of data it doesn't even need, which slows the whole operation down. Or, on the flip side, they cause underfetching, where you have to make 3 or 4 separate API calls just to build a single page. AEM's GraphQL APIs, though, they're like a custom, all-you-can-eat buffet. It's a single query-based API call where you ask for and receive exactly the data you want, no more, no less.
Okay, moving on to Section 2. Using the GraphQL IDE to test and debug.
AEM actually includes a fantastic built-in tool called the GraphQL IDE. Yep, that's GraphQL with an I in there. This is your playground for testing and debugging queries, and the workflow is super straightforward, just 4 deliberate steps. First up, you select your endpoint from the top right dropdown. This scopes your query to a specific project config, so you're only digging through content that actually matters to your app. Second, you just input your new query right there in the editor panel. Third, hit the play button to execute it, and boom, you instantly see your JSON results side by side. And fourth, listen, this is literally the most crucial step for your production environment. You hit Save As to save it as a persisted query. You really don't want your front-end apps sending these massive complex query strings over the network every single time a page loads. Saving it as a persisted query creates a neat, incredibly cacheable endpoint right on the server.
Honestly, what makes this IDE a real game changer is how much confidence it builds for you as a developer. You aren't just typing blindly into some text file, crossing your fingers that you remembered the field names correctly. The IDE gives you real-time syntax highlighting, and it actually auto-completes fields for you because it already knows your content models. Seriously, you can pretty much avoid digging through AEM documentation because the schema documents itself right inside the tool. On top of that, there's a document explorer to browse all the available methods and fields, and a really handy panel to manage your query variables. It is the perfect little sandbox for crafting your queries.
Let's keep rolling. Section 3, AEM GraphQL integrations. Let's look under the hood.
To really wrap our heads around how this works, we need to compare AEM GraphQL APIs with the older traditional AEM content services. The big difference here is all about how the content is treated. With traditional content services, your schema is defined by AEM components. The actual content lives inside those components, and it's delivered as component exporter JSON. Now, an AEM component inherently cares about layout and styling. It cares how things look on a page. But AEM GraphQL APIs, everything is driven by content fragments. A content fragment is just pure, unadulterated data. It does not care about design at all. Your schema definition comes directly from structured content fragment models. The pure content lives in the content fragments, and it's delivered in super efficient GraphQL JSON. Content fragments really are the absolute beating heart of AEM Headless.
Moving right along to Section 4, let's look at some example AEM use cases and practical scenarios.
One of the coolest and honestly most common scenarios you'll run into is querying nested fragments. Imagine you've got a team content fragment, right? And inside that team, you have multiple person fragments referenced via a field called something like team members. With traditional APIs, getting all that data could mean multiple round trips to the server. You grab the team first, then make separate calls for every single person. It's exhausting just thinking about it. But with GraphQL, you just update a single query to grab that nested model. In one swift motion, you fetch the overarching team data and all the specific properties you want from the associated person fragments. It seamlessly builds the exact relationship your front end needs.
As the AEM documentation accurately points out, the ability to query against nested fragments is a powerful feature of the AEM GraphQL API. But actually, let me pause here and offer a quick word of caution. Nesting is absolutely amazing, but you have got to govern it. Deep nesting forces your system to calculate these incredibly complex, multi-level relationship trees on the fly. It literally has to traverse the entire hierarchy of all those nested fragments, which will absolutely chew through your server processing time. So, the golden rule? Limit your content fragment nesting to below 5 or 6 levels. Trust me, your performance metrics will thank you.
Another really brilliant use case is dynamic filtering. You can actually pass query variables directly into your query from the application. Why does this matter? Well, it means developers don't have to write a separate, hard-coded query for every single user or search term on the site. You just set a variable, say $name equals John Doe, and the query dynamically filters your content fragments based on that exact property. And it gets better. If you're querying rich media, like a profile picture, you can use the built-in image ref object. This doesn't just hand you a basic image URL. It lets you dynamically request specific data about that image, like its exact width and height, right there in the exact same JSON payload. It's so efficient.
All right, final stretch. Section 5, Dispatcher Optimization and Performance Tuning.
So, we've built our queries, we've tested them in the IDE, and they are working beautifully. Now we have to optimize the backend to make them truly production-ready. Here is the absolute critical thing you need to know. Caching for persisted queries is not enabled by default in the dispatcher. You have to turn it on. First, define the variable cache GraphQL persisted queries in your dispatcher's global.vars file. Second, you want every unique response to get its own precise etag header for validation, so you've got to configure the file etag digest setting in your virtual host config. Third, remember that the dispatcher only caches specific file types it recognizes. It totally ignores raw API calls. So you have to write a rewrite rule that adds a .json suffix to your persisted query URLs, tricking the dispatcher into seeing it as a cacheable document. Finally, if you're making cross-origin requests, do not just let your origin header pass through to AEM publish. Evaluate your core's allowed origins right at the dispatcher level inside your vhost file. Doing this at the edge guarantees secure header management and massively boosts your caching efficiency.
Now, let me throw a question out to you. If you are running an enterprise AEM instance that has thousands upon thousands of content fragments, how exactly do we handle incredibly large result sets without completely blowing past our memory limits or slowing the app to an absolute crawl?
The answer, of course, is pagination, but you have to choose the right kind. AEM gives you two options here. The first is offset and limit pagination. It's pretty straightforward. You give it a starting point, like offset 100, and a limit, like 50 items. But watch out, this can be painfully slow for large data sets. Why? Because the system literally has to scan through all 100 of those previous records in the database before it even starts returning your data. The much better approach for massive data sets is cursor-based pagination. This uses a unique ID or cursor for every single item. You just tell your query to get the first set of items after a specific cursor reference. It completely skips scanning previous records and just picks up exactly where it left off. It is highly, highly efficient.
To truly master this, let's rapid fire through the definitive checklist of AEM optimization best practices. The goal here is always to keep the initial result set loaded into AEM's memory as small as humanly possible. Number 1, always use persisted queries accessed via GET requests instead of uncached POST requests. GET requests are easily cached by browsers and CDNs, but POST requests, they usually bypass caches entirely. Number 2, filter on your top-level properties whenever you can. This lets AEM use incredibly fast JCR filtering. The Java content repository has a native index, so top-level filtering uses that index before heavy fragments ever hit the memory. 3. Use the _path field to narrow your content scope directly in the repository structure. 4.
Please avoid filtering on multi-line text fields or virtual fields. Those have to be calculated on the fly and completely bypass that lightning-fast JCR filtering we just talked about. And finally, if you're on AEM as a cloud service, you absolutely must install the Experience Manager Content Fragment with GraphQL Index package. It's essential for fast querying.
And all of that optimization brings us to this specific number, 7,200. When you execute a persisted query that is properly configured with GET requests, you are tapping into the sheer power of your CDN, your content delivery network. A CDN stores your JSON payload on a server that's right down the street from your end user, so they don't have to communicate all the way back to your origin server. 7,200 seconds, which is exactly 2 hours, is the default time to live for the dispatcher and CDN shared caches. By leaning into persisted queries, you take all that heavy lifting off your AEM published servers and deliver those exact payloads at absolute lightning speed.
We have covered a tremendous amount of ground today, right from the fundamentals of the GraphQL IDE all the way down into the nitty-gritty of dispatcher caching and cursor-based pagination. So I'm going to leave you with this final thought. Are you ready to trade your rigid API set menu for the ultimate headless content buffet? It is time to implement GraphQL, optimize that dispatcher, and completely master your AEM headless delivery. Thank you so much for